All right, a few more implications of integrated information theory. So integrated information theory argues that consciousness can be graded. So it has many aspects of panpsychism. So for example, if you just look at the mathematical calculus here, you have this particular neural network where you have, where you have this quintuplet of 3 neurons, and the 5, I just look at these 3 neurons is 0.19, but if I look at the entire network, it's 10. So the theory says this entire thing is conscious. Now you're noising it. So you're adding here more probabilistic and connectivity. This remains the same. The overall intrinsic causal power that the network has becomes weaker because there's more random events here, and the phi goes down. But this is still the maximum. You add further a noise, and then suddenly what happens? Now the maximum isn't the whole anymore, because the whole only has 0.03 integrated information. It's rather these individual triplets, the 5 of them that are conscious. So here consciousness sort of systematically goes down from 10 to 0.19. So the intuition here, which is shared by this very ancient view of looking at consciousness is probably much more widespread than we think. It's certainly my belief. If you look at possibly throughout the entire tree of life, that even very simple creatures, it may feel like something, right? This is clearly not going to feel a lot. This thing isn't going to think about its weekend. It doesn't have a lot of distinction. But there could be as simple as distinction as being versus non-being, on versus not on. IIT answers sort of this. Again, it's a very old question going back to the Greek, the mereology, the relationship between the part and the whole. So, which systems are conscious? A single bacteria, the microbiome, ants or ants colony, bees or the beehive. For us, it's really the whole cortex. I argued briefly, it's a posterior hot zone. So if that's conscious, then the individual neurons cannot be conscious, because it's always the maximum over the substrate. So you can have the 2 individual hemispheres are conscious, like if you cut in the corpus callosum, you cut the 200 million fibers connecting the left and the right, but then you have two separate minds. It is possible, and the theory tells a way how to do that. You can take 2 brains, you can do sort of the inverse of a split brain. You can start connecting brains directly to each other using some futuristic, Neuralink-like technology. And at some point, there will come an abrupt, sort of almost like a phase transition, where you add 1 more wire, and suddenly the 2 brains will be conscious as a single entity, but the individuals will disappear, will not be anymore. You can make this claim that it's very strong anti-functionalist claim. You can have 2 systems that have identical input-output table. So you can have this system here that has sort of 6 neurons that are heavily networked, and you can have the input mapping onto certain outputs. You can unfold this system, if you want, into purely feed-forward structure, where you can show that for a limited amount of time, this system on the right, the feed-forward, performs exactly the same function as this system on the left. Of course, if you look under the hood, they're very different. And IIT says the substrate really matters. It's not about input-output transitions. It's not about input-output transformation. It's really about the physical substrate. Since this physical substrate is very different, their phi is going to be very different, although they perform the same function. So it's really a very anti-functionalist argument here. All right, let me come towards the end. So in a strict sense, IIT says experience has no function, just as electric charge, in physics doesn't have a function. It's a property of certain physical system. IIT says, yes, certain systems that have integrated information, that have finite integrated information, they will have power upon themselves. It's just a feature of the universe. Now, of course, you can do this. We've done this a lot of simulation with artificial life. You can show that under evolutionary pressure, it leads to systems that have high integrated information. But that's indirect, because what's, of course, evolution selects for is behavior, right? Evolution doesn't select for internal states. Ultimately, evolution will only select on explicit behavior. So in this view, consciousness would be more like a span rail, evolutionary speaking. As I said, integrated information theory is not a theory about cognition. It's not a theory of computation. It's not a theory about input-output transformation. It is really a theory about what fundamental exists, which is causal power, particularly intrinsic causal power upon itself. And my last slide here, we could spend an entire hour on this, but it really makes this strong point, this dissociation between function and being. Consciousness ultimately is a state of being. Intelligence, no matter how you define it, ultimately it's a function. It's adaptive, complex behavior in environments that have, actors operating at multiple, time scale, etc. But the theory says, well, so you look at evolution. So evolution brought forth a series of creatures from the medusa to bees to mice to Bernese mountain dogs to Madame Curie that clearly are intelligent by human measures and clearly are conscious, and probably the intelligence of these creatures goes up on some scale and their consciousness only goes up, and that's what we expect throughout evolution. That's what we've had throughout history. But now we're in a position to engineer systems that can be double dissociated. We can, in principle, engineer, cerebral organoids that may have no behavior because we don't connect them to input sensors, or we may not connect them to output sensors, but have cortical structure. So in principle, these systems could be conscious. Right? There's now a vigorous debate in medical ethics. If you get these systems, they have a few million neurons, they begin to show EEG activity. To what extent are they conscious? Well, the theory says in principle they could be conscious. Conversely, you can engineer systems that are, very, intelligent by some measure, where you can certainly have a conversation with, but they, given the intrinsic causal power at the level of the substrate, where sort of the rubber hits the road, actually at the level of the transistor, because of their connectivity is radically different from connectivity of brains. You can show their integrated information is minuscule and doesn't depend at all on their program. It really only depends on the physical substrate and the way it's wired. So you get this double dissociation. You can get high levels of consciousness in an engineered system without intelligence, and you can get high levels of intelligence without consciousness.
Your talk was about the physical substrate of consciousness. Do you think there is a non-physical substrate of consciousness?
This theory only deals with things that have causal power. And so unless, something has to have causal power on itself or on others, if it doesn't have causal power, then it doesn't exist per IIT. I had this discussion with His Holiness the Dalai Lama, and at some point we came to incarnation. And I thought, well, look, Your Holiness, I can give you a koan of 4 words: no brain, never mind, right? So once I die, unless there's some physical substrate, it could be very esoteric, it could be, space-time waves or whatever, is spatial. But unless there's a physical substrate, there isn't anything there. So without a physical substrate, you're not going to get this causal unfolding, because ultimately it relies on causal power.
Do we actually have any understanding as to whether the currently known basis set of electrical and chemical activity is sufficient to span the space necessary to explain brain computations, let alone consciousness?
Let's put it that way. We have no evidence to suggest it's otherwise. What we don't know, we can't exclude, right? Those are Donald Rumsfeld's unknown unknowns, right? So, but right now we are going on the assumption that the brain, we have in principle all the components what limits us is the vast complexity of the brain. Look, we now realize over the last 10 years, partly through the effort of the Institute, that the brain consists of 5,000 different cell types. So think about having a computer where you not just have AND gates and NOT gates and NOR gates, but where you have 5,000 different components, and then you have a few million of each of them. This is staggering complexity, right? That ultimately, I think, is what gives rise to consciousness. We have no knowledge of any other laws that might be out there that might help us, but we have no reason to suppose either that they exist or that they are necessary to explain anything physical about the brain.
The next one is by Peter Schroeder, who asks, what about plants? Recent research by Gagliano and others would seem to justify attributing memory and learning to plants.
Hi, Peter. Yeah, so I've looked at the evidence. So I would say the evidence is promissory. It's interesting, but somewhat iffy. But you know, at least if I look at, so again, IIT says, let's look at the substrate. So you have to look at actually the plants, and you have to look at the way they're organized. They don't have, for example, anything like axons, where one neuron can reach straight across the brain to make a very specific connection with the neuron on the other side. Plants and also trees, because there's this interesting question, does it feel like something to be a tree, are sort of much more local. So in principle, it's a question that will have an answer. It may well be that a plant feels a little bit like something. I would say the current evidence for high-level learning is still very out there, but it's interesting. The other question is these networks, right? These networks of roots in forest. To what extent is complex information processing ongoing there, and could that be a substrate? Possible.
If the essence of consciousness is feeling, and if all feeling in living organisms ultimately depends on interoceptive or exteroceptive sensory inputs, how can a system without sensory neurons, for example, brain organoids, which are purely seen as derived, be conscious?
Good. Hi, David. Well, so it's a good question. What would a cerebral organoid feel like? It would probably be, so let's say it has topographic connection. Let's say, for the sake of argument, you know, I managed to build a primary visual cortex, you know, using the latest tissue technology, right? And it has local connectivity. The way it feels like, I think, would be it would have some sort of inkling of space. It wouldn't have any sense of self, of past, of future, but it would have a simple experience just of extended space. And maybe if there's local excitation, you know, maybe it has some sort of, it sees, you know, sort of something, but it doesn't interpret it, of course, because, you know, in order to say there's something, an object out there, you know, I need to have interacted with the world. So it would feel something, according at least IIT, but it wouldn't be probably anything you could recognize, unless, you know, maybe in a near-death experience, when people have, you know, these strange description of what, quote, they see, unquote.
He asks, do you think that consciousness could possibly be due to a specific physical field, for example, analogous to electromagnetism, that is not purely computational or integrated information, but requiring that in the specific physical field? So a complicated computer composed of flowing water in pipes, or say a quark field, etc., would not ever generate consciousness.
Yeah, I mean, I don't know. I'm skeptic. I know there's a number of these field theories around. I mean, the most popular candidate, of course, is the local field, you know, the electrical field. You can put an electrode in the brain and measure it. It doesn't have really the precise properties required to represent my conscious experience, the high level of very detailed granularity that I have access when I look out at the world. I mean, you know, I don't know about any other fields in the brain. The only ones I can see, you know, the only ones that can physically interact are, you know, in this sort of frequency domain, you know, using the electromagnetic waves. So, and I don't think that's involved in the brain. Although, of course, it's a side effect of highly excitable neural tissue, but it doesn't look like that supports our conscious experience.